Today we are going to talk about power and energy conversion. So we are specifically focusing on three-phase systems. Firstly, we would like to talk about distribution of AC power. So the distribution of AC power is generally through single-phase 2-wire and three-phase 4-wire. So there's always a neutral line, and the function of the neutral line is to provide a return. The neutral line is to provide a return path for the current. So three-phase AC circuits. So we have a single phase and a three-phase type of circuit. So we have a single phase AC power system, which consists of a generator connected through a pair of wires, and the pair of wires is known as a transmission line to a load. That's a single phase AC power system. Then this is a single phase 2 wires. So there's a single phase 3-wire system, which is more common in practice, which contains two identical sources. So the sources are identical in such that the peak voltages are the same and the phase angles are the same. That's why it's called a single phase, because there is no phase difference or phase angle differences. So the two sources are identical, the same magnitude and same phase, and they are connected to two loads by outer wires and a neutral. This is the neutral, outer wires. So circuits in which the AC sources operate at the same frequency but different phases are known as polyphase. So if an AC source operates with the same frequency but different phases, it's called a polyphase. So the phase angles might be different, hence they're in different phases, but if the frequency is the same, it is called a polyphase AC circuit. This is an example of a polyphase AC circuit, which is a two-phase system produced by a generator consisting of two coils placed perpendicular to each other, and the voltage generated by one coil lags the other by 90 degrees. So which means the voltage operated by this first source is leading this voltage by 90 degrees, or this one is lagging this one by 90 degrees. So we have a three-phase AC circuit. The three-phase system is produced by a generator consisting of three sources, right, having the same amplitude and frequency, but out of phase with each other by 120 degrees. So for a three-phase system, normally a balanced system, the amplitude is the same. As you can see, this is VP, this is VP, this is VP. The amplitude of the voltage, or the peak voltage, VP, is the same. Frequency is the same, but the phase angles are different. You can see here this phase angle is 0 degrees, and here the phase angle is negative 120 degrees, and here the phase angle is positive 120 degrees. So there must be a 120 degree phase difference between the voltage sources. So the three-phase system is the most prevalent and most economical polyphase system because it has got a lot of advantages. The advantages are, when phase 1 or phase 2 and 2 phases are required, they are taken from the three-phase system rather than generated independently. That's the first advantage. The second advantage is that the instantaneous power in a three-phase system can be consistent without pulsating. So instantaneous power can be consistent. So we need consistency. That's why we use a three-phase system. And this results in a uniform power distribution and less vibration of the three-phase machines. And the other advantage is that for the same amount of power, the three-phase system is more economical than the single phase. Other advantages which I didn't list include that there's higher power to weight ratio. Higher power to weight ratio simply means that we need a small transformer can produce high power. We don't need a lot of materials or a lot of material to generate high power. That's why we have high power to weight ratio. We have high power or current delivery in a three-phase system as compared to a single phase. We have an economical use of inductors and transformers. There's less vibration, like what I've said before. We have a more balanced electrical load. So those are the advantages of a three-phase system as compared to the single-phase system. So we're going to talk about a balanced three-phase voltages. So the three-phase voltages are produced in three-phase by an alternating current generator or an alternator. So what happens is that if we place our magnet and surround it by coil and then we rotate it, we produce voltages in three phases, right? So the AC generator acts as a generator of three-phase voltages with phase voltage A, phase voltage B, phase voltage C, and each phase voltage is leading the previous one by a phase angle of 120 degrees. So this first phase voltage to neutral, VAN, means voltage of phase voltage A to neutral is a phase angle of 120 is a phase angle of 0 degrees, and the second one is a phase angle of 120, and the third one is a phase angle of 240. If we look at the difference, there's a difference of 120 from 0 to here, and there's a difference of 120 from 122 to 40. So the balanced three-phase voltages, yes, conditions. Like I said before, three-phase voltages, you have same peak voltage, same frequency, but the only difference is the phase angles, which should be 120 degrees apart. So the three windings, A to A, B to B, and C to C, these three windings, right? The windings on the AC generator are physically placed at 120 degrees from each other around the stator. So this is the stator. So A to A, there's 120 degrees. B to B naught, C to C naught are placed at 120 degrees apart around the stator. The induced voltages are equal in magnitude, but out of phase by 120 degrees. This means that the peak voltage or the highest voltage produced due to rotation of this rotor or of this magnet, the peak voltage is the same, right, for all A, B, and C, but the only difference is the phase angle, which is 120 degrees. Since each winding can be regarded as a single phase generator, the three-phase generator can supply power to both single phase and three-phase loads, which is another advantage. So a typical three-phase system consists of three voltage sources connected to loads by 3 or 4 wires of transmission, as you can see here. And a three-phase system is equivalent to a 3 single-phase circuit, right? So we have types of balanced three-phase systems. We have a Y-connected phase system, which is here, and a delta-connected phase system, which is here. So as we can see, there is a phase angle of 120, 120, 120 difference to make it a 360, right? Delta connected is another form of balanced three-phase voltages. So on the balanced three-phase voltages, in the Y connected, which is sometimes called the star connected, the voltage, phase voltage A to neutral, phase voltage B to neutral, and phase voltage C to neutral are known as the voltages between the lines A, B, and C, and the neutral line N. These voltages are called phase voltages. So each phase voltage is referenced to a neutral position N. So when the voltage sources have the same amplitude and frequency, which is represented by omega, and out of phase with each other by 120 degrees, we can say that the voltages are balanced. So that is the condition. This means that if there is a phase difference of 120 degrees between each of the three phase voltages, it means that the phase voltages is balanced. Otherwise, it will be called an unbalanced phase voltage. Thank you for watching. Don't forget to like and subscribe.